Honn is not available today, and I will be delivering the talk on walk you through the 2024-2025 highlights of the Induced Seismicity research project. Today's talk is mostly anchored in three new peer-reviewed research studies that you'll see referenced throughout the presentation. ISR is a nationwide NRCan effort spanning Sydney, Vancouver, Ottawa, Quebec City, and Dartmouth. And our mandate is to close or bridge the critical knowledge gaps on injection-induced seismicity and to provide observation-based science that helps regulators manage unconventional hydrocarbon development, resource development. Three concrete advances in this project are real-time monitoring of injection-induced seismicity across Western Canada, which is fully automated using AI and machine learning delineation of the dominant geological and operational controls on induced events. And finally, quantitative mapping of seismogenic potential across northeastern BC. These studies form the backbone of the risk reduction tools that we are transferring to provincial regulators, such as BC energy regulators or Alberta energy regulators. A multidisciplinary group of seismologists, geomechanics, data scientists, analysts, and admin supports has been involved in this project. We should also thank to our research assistants and associates, including postdocs and graduate students who led much of the machine learning work over the past few years. Despite challenging logistics, we completed three major successful service trips to northeastern BC in the past fiscal year to maintain the performance of our monitoring network. One was in June 2024, the other one in July 24, and the most recent one was in March 25. And the service trips were overall successful and ensured over 95%. Continuous maintenance of this monitoring network in northeastern BC and Western Canada helps us push detection threshold to smaller magnitudes, which is currently about 0.5 or less than that for most of the area in northeastern BC. And this is a requirement for the machine learning and further seismogenic analysis that I will discuss later in this presentation. In the Induced Seismicity Research Project, collaboration with provincial regulatory agencies, especially BCER, is baked into the workflow of the project. BCER now receives our automatic earthquake solutions within minutes. As I told you, it's fully automated based on AI. And on the right-hand side, you can see their note of thank, the screenshot, which underscores the practical value of our monitoring effort. I'm not trying to advertise my contribution, just Honn put it there. And on the left-hand side, you see the user interface of a web application to monitor the status of seismicity and injection operation in northeastern BC, which is fully developed in our group. And just in 2024 alone, we detected about 16,000 earthquakes with an overall location accuracy of 100 meters and magnitude of completeness of smaller than 1, as I mentioned earlier. And so the majority of these events are felt weekly, or probably not felt at all, but we detected one event exceeded magnitude 4, which is the red light threshold in the traffic light protocol, which is accepted by BCER and AER. It occurred in mid-April last year. And this real-time intel feeds directly into the BCER and AER traffic light protocols, which aims at keeping injection operations and communities safer. But the major question is that what is the driving force or driving factors behind induced seismicity? In this research, we trained an XGBoost ensemble model on more than 300 hydraulic fracturing well pads and over 30,000 events, induced earthquakes. XGBoost is an ensemble of decision trees. It's like a deep learning model to improve the prediction performance. In this case, the prediction performance, the predictability of the model, whether an injection will cause an earthquake or not. As everyone knows, the deep learning models are such as black boxes, and we rely on SHAP analysis to identify the influential controlling factors and turn this deep learning models into glass boxes. The schematic cartoons on the left-hand side summarizes the controlling factors, with the most influential ones shown in green and summarized on the right-hand side. And the top factors are cumulative, the number of stages targeting specifically the lower middle mountain formation, cumulative injected volume from earlier nearby paths, and whether the path sits inside the Fort-St. John Graben. Fort-St. John Graben is a region of mixed faulting regimes. And per path volume and mountain formation thickness round out the top 5 controlling factors. In another yet similar study, we use the same approach algorithm, but this time to identify when or at what critical thresholds some of these controlling factors become significantly relevant. Unlike the previous study, which was done for specific well paths, this study groups the well paths into different clusters using 0.1 degree cell size and 10-day temporal window.
Am I the only one? Oh, we lost you for a minute, Ramin. Okay, we hear you now.
Oh, am I good?
Yeah, you're good. You can continue.
Okay.
Sorry.
Okay. These numbers may offer actionable planning caps for operators and regulatory agencies as well. In the last study, we examined the spatiotemporal variations in seismogenic potential associated with hydraulic fracturings within the southern mountain play of northeastern BC. In the left panel, there are individual fracking wells colored based on the corresponding target formations, either upper mountainy, upper middle mountainy, lower middle mountainy, and lower mountainy. And the middle panel shows the resulting cumulative injected volume over a course of about 7 years from end of 2017 to mid-2024. And on the right-hand side, you can see a map of seismogenic indices for the South Mountain Plate obtained from observed seismicity and frac volume. In plain language, the seismogenic index is a site-specific parameter that quantifies the susceptibility of an area to injection-induced seismicity if the area is subject to fluid injection. Warmer colors or larger seismogenic indices in the south indicate high seismogenic potential, while cool colors in the north suggest lower susceptibility. In addition, we observed that those clusters connected to the lower middle mountain host more than 90% of induced seismicity in the area, which is in good agreement with the previous machine learning results. The seismogenic index, which integrates both geology and injection parameters, it gives us a risk lens that is different from the traditionally accepted B-value of the Gutenberg-Richter relation. Using the seismogenic index and Poisson statistics, assuming that the induced seismicity events are not connected with each other, we forecast an upper bound for the largest induced event for every cluster. At 68% confidence interval, forecasts are on average 15% above the observed maxima. It's a conservative but still realistic forecast. On the left panel, you can see the observed largest magnitudes in each cluster, and in the middle panel, you can see the forecasts which are in good agreement with each other. And the right panel shows the linear correlation between the two. The same framework can also be used to predict the expected number of induced events at different magnitude levels. The model slightly underperforms or underpredicts low magnitude counts, but nails the occurrence of relatively larger magnitudes. That's actually critical because the larger ones are the events that the public usually feels and regulators flag based on their traffic light protocol. To summarize, real-time monitoring plus machine learning and statistical seismology currently form an integrated pipeline in the Induced Seismicity research project. And we observe that geological factors, in addition to operational parameters and pad level factors, can explain most of the injection-induced seismicity in northeastern BC. And the seismogenic index-based forecasts provide site-specific magnitude and rate ceilings, potentially giving industry and also regulators a science-backed early warning. And if you have questions for now, you can send Honn or me an email, and